All right, so welcome everyone to our next OISF-Suricata webinar. This webinar is titled Correlating Host and Network Data with Community ID and Security Onion Hybrid Hunter. Today is June 10th, 2020 for those that are watching this recording. Let me see here. All right, so presenting today is Doug Burks. He is the founder and CEO of Security Onion Solutions and certainly a well-known personality in the network security field and security field in general. You can follow him at Doug Burks on Twitter, as well as Security Onion Solutions at Security Onion. Before we get to Doug, though, I just have a few announcements here that I'd like to go through. Our discourse trial has ended, which means that we are officially moving most of our, or all of our public communications from the mailing list to forum.suricata.io. So if you're looking to get engaged with the community, seeking some help, or just want to see what it's like, certainly head there and sign up. It's, of course, an open forum. We are also still, as most organizations and conferences, struggling a bit with our public trainings or in-person trainings, but definitely looking at this as an opportunity to expand our virtual offerings. So continue to look for more webinars such as this, as well as our normal trainings, our courses being offered in a virtual venue. In addition to that, we hope to make some announcements soon about some of the virtual workshops that we'll be doing with some of the conferences here later this summer and into the fall. The OISF, the Open Information Security Foundation, is the nonprofit organization. We have a number of full-time and part-time developers that are ensuring that Suricata remains world-class. If you're interested in joining the consortium, there's several ways to do that, and the best place to get information is to go to oisf.net or just to send us an email at info@oisf.net. On a bit of related news then to all of this virtual discussion, we have decided to move Suricon 2020, which was scheduled to be in Boston, to 2021 in Boston as well. The dates and more information will be announced here a little bit later in the year. If you want to stay up to date on that, the best place to go is suricon.net. Finally, last announcement, we are going to continue to plan our once-a-month webinar. We did put a call out to the community via social media here a couple weeks ago. If you have any ideas, suggestions, topics you're interested in, uses of Suricata that you find interesting, please you send those suggestions, those recommendations to me. Probably the easiest way to get a hold of me is through my email, jstroshine@oisf.net, or again, you can probably find me fairly easily on social media. Okay, a couple things here I just wanted to mention before we get into Doug's presentation, and that is just how community ID works in Suricata. Doug will get into this in much more detail, but at the big picture, it's usually desirable to correlate flow data between different monitoring tools. A very good example of that is between Zeek and Suricata. Suricata supports community ID, and it's relatively straightforward in order to enable that. The Suricata primary configuration YAML, there are just two values that you have to set. The first is a Boolean to disable community ID, and the second then is a seed value that you're going to synchronize between all of your devices where you want the community ID to correlate. You'll see in the output that is generated in Suricata then a community_ID field, and there is some documentation there over at Read the Docs. This is what the settings look like in the Suricata YAML. As I said, two simple fields there, the Boolean value and then correlating or synchronizing on a seed value. And then once that is set in the Suricata output, you'll begin to see at the very bottom of that screen capture the community ID field, which you can now use then to correlate between those different output tools. The only other housekeeping thing I wanted to mention is if you have any questions, Doug is certainly excited to take those. If you would just please use the Q&A feature of Zoom. I assume we're all Zoom veterans at this point. I know I've spent more time on Zoom than probably anything else in the last few months. But please direct those to the Q&A feature, or go ahead and you should be able to ping directly the panelist. So with that, Doug, it's all yours.
Thank you, Josh. I appreciate that introduction, and I appreciate your invitation to be a part of this webinar. We certainly appreciate the OISF and Suricata and their contribution to the security community, and we're proud to be a part of that community, and we're looking forward to building up stronger relationships between our individual communities to form this larger defensive security community. because I think really what we all want to do at the end of the day is to make our adversaries cry, and we're going to be talking a little bit about that today. So let me go ahead and share my screen. All right, so that should be shared. So we're going to be talking about the power of community, and specifically, as Josh kind of talked about, Suricata and community ID, and how we kind of put those things together in Security Onion. So folks are familiar with Suricata and community ID, as Josh spoke about, but for those that aren't familiar with Security Onion, let me provide just a brief bit of background. What exactly is Security Onion? Security Onion is a free and open source platform. I'm a big believer in open source, having first heard that magical phrase of open source back in 1997. And as somebody who is frugal and sometimes referred to as cheap, open source and specifically free really spoke to me. And so I built an entire career out of open source software, even before starting my own open source project. And so I knew that at some point I did want to start an open source project, primarily to be able to give back to this amazing open source community that has given so much to me. So Security Onion, first and foremost, is a free and open source platform. Why the name Security Onion? It's to help you peel back the layers of your enterprise and make your adversaries cry, right? We all know that there's lots of information floating around on our networks, in our enterprises. And if we can get at the right information, if we can peel back those layers and we can determine that there's an adversary in our environment or trying to get into our environment, and if we can do that quickly enough, then we can interrupt the adversary before they achieve their objectives. Or even if it's after they achieve their objectives, maybe we can put together enough evidence to be able to build a case against them, maybe put them in jail, ultimately make our adversaries cry. So there are thousands of security teams around the world that are using Security Onion today for things like threat hunting, intrusion detection, network security monitoring, enterprise security monitoring, incident response, all of those kind of buzzwords that we all kind of talk about in the realm of defensive security. And because we all know that more and more of our network traffic is being encrypted, we know that it's important to focus not just on network visibility, but also endpoint visibility as well. So as more encryption happens in our network traffic, we want to fill in those blind spots with endpoint telemetry by collecting logs directly from our endpoints and being able to kind of shine a flashlight into those dark corners of our networks. So that's a brief glance at what Security Onion is, and we'll kind of talk about the history of Security Onion and how Suricata plays into that. But I do want to kind of reinforce what Josh said. If you do have questions, please feel free to send them to the Q&A, and either myself or my right-hand man, Phil Planamira, will try to answer those questions as they go along. So I started Security Onion back in 2008. You can see that very first blog post that I put out. And the original idea was to build a live CD that would allow folks to test things like Snort and other tools and components for network visibility very quickly and easily. And one of the reasons for doing this was really kind of underscored to me when I worked an incident, and I realized during the course of that incident that the adversary, the bad guy in this case, was actually using Backtrack Linux, which is now called Kali Linux, which is a Linux distribution that's got all the attacker tools ready to go, already compiled, already configured. And it became readily apparent to me that it was fundamentally unjust that attackers have their tools already compiled and configured and ready to go. And yet we as defenders didn't really have a great equivalent of that. So in order to try to balance the scales, in order to try to find some sort of advantages, I decided to set out on this journey to build this Security Onion Live CD. So I started building it in 2008 and put the first version out in 2009. And then came this great project called Suricata. So we added Suricata to Security Onion in 2010. And you can see there that at the time when we did that, we actually, we were hosting the Security Onion ISO image at the Emerging Threats website. So we had a really good relationship with Matt Yonkman and the Emerging Threats team. And so we were looking for some hosting. It was kind of difficult at the time to try to find folks that were willing to host a 1 gigabyte or larger ISO image. Back then in 2010, of course, bandwidth, which was much more expensive than it is today. But that was, quite nice of Matt and the Emerging Threats team to volunteer to allow us to host our ISO image there. So we appreciate that relationship that we've had throughout the years with the entire team there. And in 2011, we upgraded to Suricata 1.1. And, so it was important to me to kind of demonstrate to the community that we are going to keep pace with components as they come out. And the last thing that anybody wants is to be running a production network sensor with components that are old and outdated and more importantly, vulnerable. Right? Because by rolling these network sensors out, we're trying to increase our visibility, we're trying to increase our security, but if the components are old and outdated and vulnerable, we're actually making our security worse. So it was important to me to, as we're kind of building the community behind Security Onion, to keep pace with all the components, including Suricata, and rolling out new versions when necessary. And so we started that with Suricata 1.1 way back in 2011. The next year in 2012, because Security Onion is based on Ubuntu, and Ubuntu 12.04 came out, it was time to rebuild the distro from scratch. And at this point, we were a couple of years into the project. The community was growing and thriving. More and more folks were using Security Onion in production. We had kind of moved beyond the early days of just being a live CD and actually turned into something that was installable, something that was production ready, something that could be usable for a network sensor and maintainable over the long term. So because of that, we had more and more folks that were deploying on larger and larger networks. And so it became very important to then be able to scale components like Suricata up to higher amounts of network traffic. And back in 2012, really kind of the best way to do that from a free and open source perspective was with PF-Ring. So PF-Ring is a kind of a flow-based load balancer that is a kernel module and a user space library. And, so we went through the hard work of building that kernel module and compiling Suricata against that user space library and building all of that tooling associated with that so that you could install Security Onion, you could run Suricata, and it could take advantage of all of those CPU cores that you had in your box. And at the same time, because we were kind of rebuilding the distro from the ground up for Ubuntu 12.04, we built everything into standard Ubuntu packages hosted in a Launchpad PPA. And that way, everything was standardized, every package was signed and secure. And so that was kind of a big step in our journey towards being a much more enterprisey sort of a free and open source project. As I mentioned before, it was important to us to really keep track of releases as they came out. So when Suricata 2 was released, it was important for us to then upgrade our Suricata packages. And so we released Suricata 2.0.3 in 2014. And throughout the years, we continued to keep pace with those releases. So for example, in 2016, we released Suricata 3. 2017, we released Suricata 4. And in 2018, we released Suricata 4.1. Now, the following year, in 2019, going back to what we said in 2012, we did our initial kind of scaling our load balancing using PF ring. And over the years, AF Packet has grown to become kind of a mature implementation built into the kernel, so it doesn't require a separate kernel module. So it becomes much easier to support something like AF Packet. So in 2019, we made the move to start supporting AF Packet on new installations, and that works really, really great, getting some really great performance out of that, and a lot less maintenance because we don't have to rely on that sort of external kernel module. That brings us to 2020. And so in March, we released Suricata 4.1.7. In April, we released Suricata 4.1.8. And so that's where we are today in our standard current Security Onion platform. If you go and download our ISO image, you're going to be running Suricata 4.1.8. And let me kind of talk briefly about what that looks like because of kind of the history of our project and some of the other components that we have built into Security Onion. The way that we have Suricata configured in the current platform is it's limited to just network-based IDS alerts. We'll talk about some of the other features of Suricata a little bit later in terms of protocol metadata and other types of logging. But in the current platform, Suricata is really focused on network-based IDS alerts. We kind of surround those network-based IDS alerts with Zeek protocol logs. And that's kind of where kind of our main topic of discussion comes from today, because as you're looking at Suricata network-based IDS alerts and you're trying to correlate those to Zeek metadata logs, Community ID really becomes that one thing that ties those different kinds of logs or different data types together. And we'll talk about some examples of that later, but to sum it up, in the current platform, Suricata just running network-based IDS alerts and just outputting to kind of a traditional unified 2 format, and we'll kind of talk about moving to eve.json a little bit later. So that's kind of where we are from a network perspective. But as I mentioned towards the beginning, we're very much focused as a platform on providing not just the best of breed network visibility, but also the best of breed endpoint visibility. And so we want to make sure that we're integrating with the best components out there for collecting telemetry from your endpoints. A lot of folks really like the Elastic Beats family. So you have WinLogBeat, you have FileBeat. These are great agents that allow you to collect those logs and ship them to an Elastic backend, which we'll talk about a little bit more in the next slide. But that's one option that we integrate quite well with. The next option is Wazoo, which is kind of the next generation version of OSEC, which is a tool that's been around for a long, long time. It's cross-platform. It's a master client-server architecture where you deploy cross-platform agents out to your Windows endpoint, your Mac OS, Unix, Linux, FreeBSD endpoints. And Wazoo is great in that it's gives you log collection, it gives you log analysis, it gives you encrypted log transport, it gives you file integrity checking and rootkit detection, all in one very minimal agent. So that's a great solution for endpoint visibility. And then kind of next on the list is from a Windows perspective, because for many shops, the vast majority of their endpoints are running Windows. And it's very important to have some good comprehensive visibility into those Windows endpoints. We all know and love Sysmon, written by Mark Russinovich and the sysinternals team at Microsoft. And we know that Sysmon gives really great comprehensive logging for things like process creation and network connections and DNS lookups and things like that. So we've done a lot of work to integrate quite well with those Sysmon logs and consuming those and parsing them and really giving folks the ability to slice and dice those Sysmon logs and get that endpoint visibility that they're looking for. Now, let's say that you have some sort of an incident and one of your machines is compromised with a piece of malware, which has a persistence mechanism. You might want to look for different kinds of persistence mechanisms. And there's another tool in the sysinternals toolkit called autoruns, which is a really great way to do that. Autoruns gives you good visibility into a lot of different persistence mechanisms in the Windows operating system. So again, one of our guys, Josh Brower, has done a lot of great research and a lot of great work in terms of integrating with autoruns and presenting that data to help folks look for those strange looking entries that might exist in those autorun entry points in the Windows registry. And then finally on the list here is osquery. osquery is another great cross-platform tool. So it works on many different operating systems. It gives you the ability to collect logs from those endpoints. It gives you the ability to run queries, live queries against those endpoints. And it's a really great utility. And we'll talk a little bit more about that a little bit later. So now let's say that you have deployed all of these network components. So you've got Suricata and Zeek monitoring your network traffic. Suricata is generating network-based IDS alerts. Zeek is generating metadata protocol logs. You've got agents deployed out to your endpoints. That might be Wazoo or Elastic Beats or any of those others that we mentioned. And so now you need a place to store all of that data so that you can then slice and dice it and look for those adversaries that might have a foothold in your environment. So most folks are familiar with the Elastic Stack, formerly known as the ELK stack for Elasticsearch, Logstash, and Kibana. So a few years ago, we integrated the Elastic Stack right into Security Onion. So we used Logstash to collect the logs and then ship those logs to Elasticsearch where they're then stored. And then we use Kibana to allow you to log in as an analyst and start looking at dashboards and visualizations, running searches to look for those anomalies, to do your threat hunting, and to find those adversaries that might be hiding out in your environment. So that's a brief look at kind of the architecture of Security Onion in terms of the components that we have. Now let's look at the architecture in terms of how you actually deploy the thing. So if you've never used Security Onion before, you might start out with a small little virtual machine, which we might consider a forensics VM. So you can take our Security Onion ISO image, you can download it today, and you can install it in a small little virtual machine. And you could run a command that we have called so import pcap. And that utility will take one or more pcaps and import them into Security Onion and preserve the original timestamps in those pcaps. So if you have your own favorite pcaps, you can run those through so import pcap. If you don't have your own pcaps already, you can grab some pcaps from Brad Duncan's great site, which is malwaretrafficanalysis.net, or you can use some of those malware traffic analysis pcaps that we've already included in the opt samples directory. And so when you run that so import pcap command, it's going to run that pcap through Suricata to generate those network-based IDS alerts. It's going to run that pcap through Zeek to generate those protocol metadata logs. And then it's going to take all of those alerts, all those logs, put them into the Elastic Stack, and then you'll be able to log into Kibana, and you'll be able to look at all of that data that came from that pcap. And you can do that very quickly and easily in just a few minutes. So it's a great way to get your feet wet with Security Onion if you don't have any prior experience with it. Now, once you have some experience with Security Onion and you're ready to kind of go to the next step, you might be wanting to stand up a production deployment. So the first time you do that, you might want to stand it up in your home lab. You might have a lab at the office that's just kind of a sandbox that you play around with technologies. Or you might have, just a small office network that you're trying to protect. And so for some of those use cases, you might be able to use kind of our standalone deployment, where you install a single standalone Security Onion box, you put it into production mode, it's sniffing your network traffic. So you could have Suricata monitoring your network traffic, generating those network-based IDS alerts, Zeek monitoring your live network traffic, generating those protocol logs. And then you could deploy some agents out, and you've got your Elastic Stack sitting there on that standalone box. And so you could have a single standalone box. Again, it's not going to scale up to really large enterprises, but it's a good way to kind of take that next step and kind of starting your production deployment. Once you start to reach the limits of how much you can do with a single box, or once you start to get to the point where you want to monitor additional network segments or other remote offices somewhere else where you might want to stick another box, then you start looking at our distributed deployment. So we have a fully distributed deployment model where you can have a central server, and that's then going to manage all of the other nodes in that distributed deployment. So you could have one or more forward nodes. Those are going to be your network sensors that are running Suricata and Zeek. And then you could be collecting all of those logs from all of those forward nodes and sending them to backend nodes to store those logs. And so we call those storage nodes. So that distributed deployment model is designed to scale. So as you're monitoring traffic, as your monitored traffic increases, you can add more forward nodes, you can add more storage nodes, you can continue to snap nodes into the grid as necessary to scale it up to your needs. So once you kind of understand the architecture of the components, the architecture of how you deploy the thing, how do you actually get started? How do you actually download and install Security Onion? The easiest way to do that is to download our ISO image. It's been downloaded over 1 million times. That's the primary method that most folks use. It's got everything built into it. You can take that to air-gapped networks because everything is built into it. It doesn't have any external dependencies. And so you can do that. You can be up and running in just a few minutes. Or if you prefer, if you don't want to use our ISO image, you can always take your own preferred flavor of Ubuntu 16.04 and then install our components on top of that. So we've got directions for both of those methods on our documentation site. So whether you're deploying via ISO image or even installing Ubuntu server, just a minimal installation, and then adding our packages, we've got step-by-step instructions for each of those deployment methods. So now over the years, we've seen a number of other community projects kind of spring up, and we've seen a lot of value and a lot of synergy between these other community projects and Security Onion. And so we'll kind of talk about just a few of those here today in these next few slides. So the first that I'll mention is Sigma. And so if you're familiar with Suricata, you're familiar with the concept of writing a Suricata rule that's going to match on particular network traffic. Well, Sigma is kind of the same thing, but instead of matching on particular network traffic, it's going to match on particular log entries or log events. And kind of the brilliant thing about Sigma is that it has this Sigma converter, which allows you to kind of plug in different backends. So you could write kind of a generic abstract Sigma rule for a particular kind of log event, but you can have it converted to work across Elasticsearch or Splunk or whatever kind of backend database you have that's storing your logs. So Sigma is a really powerful tool. We've seen a lot of folks integrate with Sigma and do some really cool things there. And you can check that out at the GitHub link listed there. Now, if you take that to the next level, one of our folks, Josh Brower, he did some really great work in putting together what he calls Playbook, which is a great way of kind of taking those Sigma rules and say, I want to import this group of Sigma rules, and I'm going to go through that list. You can kind of see a screenshot on the right side there. I want to go through this list, and I want to activate certain Sigma rules. And then when we do that inside of Playbook, it's then going to set up ElastAlert and run ElastAlert on a scheduled basis to search across our Elasticsearch instance. And any hits that we find, any matches that we find, are then going to generate alerts, which then go into the Hive. What is the Hive? Well, let's talk about that. The Hive is another great community project, which is a web interface for incident management. So suppose you're in a security operations center, you've got multiple SOC analysts, you're all trying to defend your enterprise, and so you have alerts coming into the Hive, and for each of the alerts, you can decide, okay, if this is a true positive, I might want to turn this into a case. And so once I'm working this case, then I can add my notes, I can add any indicators to the case, and ultimately, whether I'm working the case or one of the other analysts is working the case, we can all work together in the same incident management system and ultimately work that case to its completion and then close that case and save all of those case notes in case we need to refer back to them later. So then the next thing that you might want, another great community project, if you start deploying osquery across your enterprise, as we mentioned earlier, you might want to look at Fleet to manage all of those osquery instances, all of those osquery agents. And so you start to see how kind of all of these different components fit together and the entire kind of life cycle of security monitoring and security incident management, where you bring in new Sigma rules, you activate them in the playbook, it starts searching across Elasticsearch, it generates hits in the Hive, you start investigating those. Maybe you're going into Kibana and you're doing some extra searches to figure out what's going on. Maybe you go into Fleet and manage your osquery deployment from there, but you start to see how all of these different components fit together and help you in your objectives to finding adversaries faster and getting all of the information that you need to kick them out of your network and potentially make a case against them once you start bringing in law enforcement or however that case ends up going. So now you could take the current Security Onion platform and you could build all of those extra community projects around it, and you could do that integration work. Or you could just download our new platform, our next generation platform that we've codenamed Hybrid Hunter. This is a platform that we've been working on for a couple of years now. It's currently in beta 2, so it's not fully production ready yet. But you can download it today, you can play with it, and it's already got Sigma built in, it's already got the playbook, it's already got the Hive, Attack Navigator, Fleet, Grafana. All of these great components are built in addition to a lot of that other stuff that we talked about previously in terms of Of course, Suricata is built in, Zeek is built in, all of our standard network visibility stuff is built in as well. So what's kind of different about Hybrid Hunter? Why the new platform? How is it different architecturally? I mentioned earlier that our current platform is based on Ubuntu packages. And so that limits us really to running on Ubuntu itself. And so kind of the number one piece of feedback that we've had over the years is, can I run Security Onion on Red Hat or CentOS? And so when we set out to design the next generation platform, we said, okay, we want to be able to embrace Red Hat and CentOS. So in order to do that, we fully embraced containers, and that allows us to be much more flexible. And so we take those containers and we orchestrate them using SaltStack. SaltStack is an orchestration technology similar to Ansible or Puppet or Chef. And so that SaltStack orchestration that we've built currently supports both CentOS 7 and Ubuntu 18.04. So you can download Hybrid Hunter today. You can download an ISO image, and that's based on CentOS 7. Or you can install Ubuntu 18.04. You can install Hybrid Hunter on top of that, and it works either way. So that's an overview of our new Hybrid Hunter platform. As I mentioned previously, it is currently at beta 2, and the guys on the team are furiously working on beta 3 as we speak, which will have Suricata 5 and will include metadata logging from Suricata. So this is something we've been talking about for a long time. We know that Suricata has this capability of doing that metadata logging. It can log HTTP connections and DNS requests and things like that. We want to be able to give our community that choice to be able to enable that Suricata metadata logging. So we are working quite heavily on that to make that a reality. Another new thing that we've added is a brand new web interface for threat hunting. And so you see a screenshot of that there. And so really to kind of tie this back to the very beginning of this, when Josh was talking about community ID, he talked about how you go into Suricata, you go into suricata.yaml and you enable that community ID. In Hybrid Hunter, we've already done that for you. So when you spin up Hybrid Hunter, it's going to have Suricata running. Suricata is already configured to enable that community ID support. And so you can go into our new threat hunting web interface and you can run this query. If you look at the query at the top, it's going to look for all Suricata alerts, and it's going to then pipe that into a group by. So it's going to group by the community ID field, and you can see the results of that at the bottom of the screen. Now, likewise, Hybrid Hunter is enabling the native community ID support in Zeek. So if you choose to run Zeek for your protocol metadata logging, then you're going to have those community ID values, and that then allows you to quickly and easily correlate between the Suricata logs and the Zeek logs and vice versa. So you can go back and forth. Now, in addition, we wanted to take that a step further. So we said, okay, we like osquery from an endpoint standpoint, and we'd like to be able to, if we find an interesting network traffic flow, and we've got this community ID value that represents that network traffic flow, how could we then search across our osquery fleet for more information about that particular traffic flow? So we sponsored the development of community ID support in osquery itself. So now osquery natively out of the box supports community ID. So you could run an osquery query like this, which is going to look for a particular community ID, and then it's going to return back the process on that endpoint that created that traffic flow. So in this case, we see that the traffic flow was created by Netcat. So Netcat was trying to connect to osquery.io on port 443, And we can tell that very quickly and easily by running that community ID query against our osquery agents. So the next question is, what about tools where we can't easily add that native community ID support? You know, osquery was relatively easy because it's open source. We paid a developer to write the code and contribute that as open source. And so now that's built in. So that was relatively easy. But what about things like Sysmon? Sysmon is not really open source. There is an issue out there on the Sysmon GitHub repo that is requesting community ID support. And that issue has been accepted as a suggestion. It's been added to the backlog, but we don't know when exactly that will be supported. Now, that's just one example. There's lots of other examples of closed source software where you're not going to be able to submit a patch or do any other changes like that. So it's important to be able to have some sort of an option for that. So here's what we did. We said, okay, well, all of our logs are coming into Elasticsearch. And we have, whereas our traditional parsing may have been with Logstash, we've, over the past year or so, started transitioning from Logstash parsing to Elasticsearch ingest parsing, meaning that Logstash may transport the log to Elasticsearch, but Logstash isn't actually going to parse it. Elasticsearch is going to parse it itself. And so what if we built a processor for Elasticsearch ingest node that could generate that community ID? That then means that any log that you send into Elasticsearch, as long as it has the proper IP import information, we can now generate that community ID field on the fly. So it doesn't matter where the log came from. It doesn't matter whether it was an open source tool or closed source tool, whether it has native community ID support or not. We can now do that across the board. So we're pretty excited about that. And that is going to be available in Hybrid Hunter Beta 3. I have a very quick demo of that we can take a look at so you can see what that actually looks like. So let's see if I can flip over to my demo. So here you have our new threat hunting interface. And so what I thought I'd do is fairly quickly go through 3 different use cases. And so what I've got here is I've got a Hybrid Hunter virtual machine that is running kind of our development version of unreleased beta 3. And so in this Hybrid Hunter VM, I am running Suricata to monitor my network traffic and generate network-based IDS alerts. I am running Zeek to generate my protocol metadata logs. And then I also have an endpoint, a Windows VM that's running Sysmon to generate that comprehensive logging of network connections and process creation and DNS lookups. And those logs are being collected by WinLogBeat on that Windows endpoint, transported to my Elasticsearch instance on my Hybrid Hunter VM. And then those Sysmon logs are then being decorated with our automatically generated community ID values. So we want to look at 3 different use cases here of how you can take those 3 different data types and pivot from one to the other. You start to see how the different data types fit together and how they can complement each other, especially when you're working your incidents and you need just that little bit of extra information to help fill in the gaps, that little bit of context that really helps to paint the picture. So let's start with our first use case. And so for this use case, I'm going to start with a Suricata network-based IDS alert. So suppose you're monitoring traffic coming off a tap or a span port. You've got Suricata generating network-based IDS alerts based on the emerging threats rule set. And so inside of our threat hunting interface, we've run this default query, which is available in this drop-down box which looks for network-based IDS alerts. So again, we're just looking for network alerts, and we're grouping by rule name. So this is going to show me all of the unique alerts that have been generated by Suricata. So at this point, I've got a certain number of emerging threats alerts. So I'll look through this list for something that might be interesting. So maybe I might focus in on this rule, which is from the policy category. It's for an executable served from Amazon S3. So if I want to filter based on that, I'll click the plus sign and then click Hunt. So that filters my results down to just that one particular alert. And then in the bottom events table, that's where I can find all of the detail of that particular alert. So I see one row here. I can drill into that by clicking the drop down. And that shows me all of the detailed fields that are contained within that Suricata alert. So we can see that this came from Suricata eve.json. So we've switched from unified 2 to eve.json, and we're getting that really rich output from Suricata now. We can see executable served from Amazon S3. We see the rule that generated that alert. And all the other information like source IP, source port, etc. Now, where this gets interesting is where we start to involve that community ID. And in this bottom data table, we expose that community ID by default. Because yes, we can get some information from the Suricata alert itself, but we might have other context from other vantage points on our network. So let's leverage that community ID to see what else we can find. So I'm going to select that. I'm going to go up here, and then I'm going to search for that particular community ID. Here's where it really gets cool, because now I see not only one match for that community ID, but I see 6 events, all matching that community ID. I see that the first 2 have a UID field, and that tells me that these are Zeek logs. Because this is port 80 traffic, I'm going to assume that one of those is a connection log and one of those is an HTTP log. So I could drill into the first one here, and I could see, yes, this is a Zeek connection log. I could drill into the second one, and I could see, yes, this is a Zeek HTTP log. And so again, this might provide some additional context that we might not have seen in the Suricata alert, but we know that those Suricata alerts are pretty comprehensive. So let's see what else we might be able to find if we look a little bit further. Looking at this list, let's look at these bottom 2. So this first one that we have is our Suricata alert, but this is actually a different alert. This is for a Windows EXE. So yeah, it's basically the same alert, but it's a little bit more generic because it's looking for any EXE, not just an EXE from S3 as the original alert that we looked at, which should be this one right here. So at this point, we've kind of looked at the first 2 matches. We've looked at the bottom 2 matches, but now the question is, what are these kind of middle 2 matches? So if I kind of drop into here, I can see, well, here's another Suricata alert. And this alert is actually for a curl user agent. So whatever kind of traffic this was originated using a user agent that matches the curl library or the curl binary. So now let's kind of drill into our last event here. And this is where things get interesting because this came from WinLogbeat. And furthermore, it came from Sysmon. So now I can see that this was, all of this traffic originated from a Windows host. And because it was on a Windows host running Sysmon, and WinLogbeat was collecting those Sysmon logs and transporting them to our Elastic Stack, we now can search across that, especially since Elasticsearch generated that community ID that we needed to be able to correlate across our different data types. So that then shows us that the original process executable was actually curl. And so you can actually tell by the path here, this kind of simulated security incident was actually Windows subsystem for Linux. So I took a Windows VM, I installed Windows subsystem for Linux, installed Ubuntu, and then ran through testmynids.org and some of the simulations that they have. And so that's some of the stuff that we're looking at. But the power that you see here is being able to correlate back to the actual process that generated that network traffic. So now we have really kind of that complete picture that we've painted about what happened from start to finish. And if we want to go even further from kind of a network perspective, if we want to see our full packet capture, we can, of course, pivot over to PCAP. This is going to go out to Google Stenographer. It's going to reconstruct that TCP stream, render it as an ASCII transcript. And so now we can see where curl reached out to testmynids.org, requesting calc.exe. It got the response back from the server, and there you can see the MZ file header for that particular Windows exe. So it's pretty amazing to see all of those different data types being able to correlate between them using that community ID field. So that's use case number one. Now let's take a look at use case number two. For the first one, we kind of started with looking at a network-based IDS alert. Now, when we talk about threat hunting, we usually define threat hunting as looking for something without having an alert, right? Going out and looking across all of our non-alert data types for those anomalies, those kind of strange things that kind of stick out like a sore thumb. So we have a number of default queries here in our threat hunting interface. And if I scroll down this list, I do have a number of queries for HTTP, and specifically for HTTP grouped by user agent. So now this is always a fun thing to look at, is take all of your network traffic and look at your HTTP user agents. It doesn't matter whether you're running Zeek or whether you're running Suricata to do your protocol metadata logging. You can take those HTTP logs, you can group by user agent, and then you can look for those anomalies, because your standard enterprise user agents are going to be Internet Explorer, Chrome, Firefox, those usual browsers, and a few other utilities that you expect to see on your enterprise networks. But then you start looking for these strange looking user agents like Black Sun or MSIE, which is not a legitimate Internet Explorer, or just agent. Or in this case, we might focus in on Jedi VCL. So again, we click the plus to refine our search. We click Hunt. And our new search results includes just one HTTP log. So again, I could drill into this. I could see all of the nitty-gritty details in this particular HTTP log. But where this gets more interesting is pivoting on that community ID. So if I copy that and then go and search for that particular community ID, very similar workflow to what we saw before. We get multiple results here. A few of them have a UID, so that tells me that these are Zeek logs. One of them would be the HTTP log that we just looked at. The other would be the Zeek con log. And then that leaves these last two here at the bottom. So let's take a look at those. This is number 3. That's when LogMeet. We'll come back to that in a second. And so this fourth one, this is actually our Suricata network-based IDS alert. And so even though we didn't start this particular search coming from an IDS alert, the point of this second use case is that sometimes even when you're doing kind of anomaly-based threat hunting, you might then be able to pivot to alerts and find that, oh, there actually was an alert, which might give me some additional context for what that anomaly actually is. And that's exactly what we see here. Because in this case, Suricata is telling us that this particular user agent has been seen in relation to the Delphi Trojan downloader. And that gives us more information than we had just by looking at the raw HTTP log. So that gives us some additional context, some additional intelligence. So now let's go back to our WinLogBeat entry here. And again, we can see that this is WinLogBeat pulling a sysmon log, and we can see the process executable, again, was Windows Subsystem on Linux running curl. And this was another one of those tests from testmynids.org. So this is really just kind of simulated malware, but you start to see how all of these bits and pieces fit together to paint that picture and allow you to correlate between different data types. So that was use case number 2. Now let's look at use case number 3. So in use case number 1, we started with a Suricata alert. In use case number 2, we started with a Zeek HTTP log. In use case number 3, let's start with a sysmon log. So in this case, what I want to do is go up to one of my preformed queries that's going to show me really all of my data types, and I just want to focus in on WinLogBeat. So now I have a bunch of output here. If I start paging through here, I should start to see some logs that have IP addresses. And these specifically are going to be coming from sysmon, where it's seen network connections. So maybe I might want to say, well, this is an interesting IP address. Let's filter based on this. So I click on Hunt. And so now I can page back to get back to the beginning of my results. So I've got a number of results here. And so what I might want to do is sort of collapse this down, because I don't want to go through these entries one by one. So maybe what I might want to do is group by destination IP. So to do that, I find this destination IP field and I click the icon to the left. So that's going to update my query up here to say group by not only event module, but also destination IP. When I click Hunt, that's going to refresh my screen. You see I'm grouping not only by event module, but also destination IP. And that makes it a lot easier because I've now consolidated the large list down here into just the unique destination IPs. And so I've consolidated 13 entries here into just this one destination IP. So it's a lot easier to look through this list for anomalies. So now let's take this a step further, and let's suppose that you recognize this particular IP address, 8.8.8.8, as the Google DNS server. And you say to yourself, well, you know, our internal workstation should really be pointing to an internal DNS server. They should not be connecting out to Google DNS at this IP address. So this might be an anomaly. We might want to filter in on this particular value and investigate that and see what's going on. So we do that search, and that filters us down to 4 results here. So if I drill into the first one, what I'm going to see is that this is, of course, WinLogBeat. This is a network connection detected. Again, this came from Windows Subsystem on Linux, but in this case, it was running dig. And so this was actually a DNS lookup using dig on a Windows box and going out to 8.8.8.8. And so we see all of that from kind of the sysmon perspective here. But as we talked about before, we can get a little bit more detail if we then pivot based on that community ID. So if I run that search, I now have 5 events that match that community ID. The first 2 have a UID that tells me they're Zeek logs. So one's going to be the Zeek con log and one's going to be the Zeek DNS log. And in this case, because Zeek saw the network traffic, it's going to show me the actual DNS query. So here I can see just this random string of characters .onion. So that's an interesting query in and of itself whenever I see a random string of characters. So let's see if we can find some more information about that. The second one here is going to be our con log. let's take a look at our result number 3. This is win log beat. So that's probably what started off this whole search. That's dig. Let's go to number 4 and see what we can find. So this is a Suricata alert for Tor hidden domain.onion. So if we had looked at that Zeek DNS log, but we didn't kind of correlate mentally that .onion had to do with Tor, the onion router, well, then this alert is going to give us that extra information that we need to make that connection. And then finally, if we look at this last one down here, we see this is another Suricata alert. And in this case, this gives us even more description about this one particular .onion domain. Not only is it related to Tor, but it's been seen in relation to the crypto wall Trojan. So now you really see from 3 different perspectives the ability to use community ID to tie together different data types and give you that much more information about what's going on in your network so that you can then paint a more complete picture about what the adversary is trying to do, what they have done, or what you need to do to interrupt their actions before they achieve their objectives. All right, so that was my demo. At this point, I'll kind of wrap it up and say that we absolutely love Suricata. We love community ID. We love being able to tie all these things together. We love the Suricata community as a whole, and we're proud to be a part of it. We're looking forward to finding more ways to work together as a community and making our adversaries cry. You can find us at the URLs there, securityonion.net. And at this point, I will turn it over to Josh to see if he has any closing words or if there's any final questions that I can answer.
No, I thank you very much, Doug. Awesome presentation as usual. Very informative. Oh my goodness, excuse me. Just one brief announcement. It's been asked a number of times. We did record this session. We will be putting the video here somewhere, likely on YouTube, and we'll get that information pushed out here in the next couple of days after we've had a chance to edit out some of the Q&A and stuff. We'll also be putting slides with that in PDF form. So for those of you that were looking for that information, it will be out there. I'd say at this point, Doug, it's just up to you. Maybe we have time to answer a question or two. I think you did an awesome job, though, of between you and Phil getting most of those questions answered along the way. So let's see. There's only one question still pending, and that is the beta period for Hybrid Hunter. Do you know how long that beta period will last?
How did I know that question would come up? So we are currently at beta 2. And my team is working feverishly on beta 3 as we speak. We hope to release that real soon now. And once we get through beta 3, then we start to look at release candidates. We expect to have release candidate 1, release candidate 2, release candidate 3. We're not really promising any dates at this point in time. I'll just leave it at the fact that we are hoping to reach a final release for Hybrid Hunter at some point this year.
Awesome. Last question then. Any plan to integrate MISP?
That's a really good question. I know we've had lots of discussions about MISP. I am not the expert about MISP, so I would have to kind of defer that to Wes Lambert, who's not on the call today, but we can certainly check in and see if we have that on the roadmap. And, if it's not already on the roadmap, if you want to put it in as an issue, I think we might actually have an issue out there already. So you might check our GitHub for Hybrid Hunter and see if it's already listed there and see if it is on the roadmap.
So right. I think, Doug, it's Phil. I'm sorry to interrupt. I think MISP is on roadmap, and I believe if you go out to our integrations page, securityonion.net /docs/integrations, you'll see how to integrate MISP today.
Perfect. Thank you, awesome. Phil.
Okay. Well, I think since we're just a little over, we'll go ahead and wrap things up if that sounds good to you, Doug and Phil. Thank you again both for joining us today. It was Suricata feels the same way. A lot of love going both ways, and we certainly hope to continue to explore opportunities to do similar type of events in the future. So, if you guys have any final comments or words, otherwise, I think it's time we wrap things up.
Awesome. Thanks, Josh. Thanks, everybody.
All right. Thank you, everyone, for joining. Look for the video and look for our next webinar here in July.